Hi everyone! In this lecture, I will show you how we can convert another real-life example into a system of linear equations, and then I will also show you how we can solve the system. Alright, then here's our scenario that I've just made up for you. Okay, suppose we have a patient or someone, doesn't matter who he or she is, that is required to meet the total amount of vitamins after following a certain sequence of days. And here's the statement of the problem. Well, say the beginning of the statement of the problem. Say we have three different vitamins that someone needs to have after following a sequence of days. In other words, how many days later we don't know he will meet the requirement, but we will try to find it. Okay, say vitamin A, vitamin B, and vitamin C. Let's say these are the constraints or restrictions that we need to satisfy. And say the vitamin A, the amount of vitamin A should be 20 milligram, and vitamin B is 30 milligram, or whatever unit we take, doesn't matter. And vitamin C is 20 milligram. So this is the first constraint. And to obtain the amount of these vitamins, this patient is allowed to take either of the following three pills that are legal to use. So say them X, Y, and Z. Let's name these pills like X, Y, and Z, okay? And let's draw a small table where we can see all the data. Okay, here's X, Y, Z, right? In the rows, and in the columns, let's put the gain of using these pills. In other words, if I use or if I take these pills, what is the amount of vitamins that I would either increase or decrease? Okay, so here's the thing. You will understand what I mean by that. Okay, let's do this. Let's draw these lines. Okay, here's the thing. If the patient takes the pills namely X, okay, then within 1 day, in other words, within the first 24 hours, and by the way, again, our measurement unit is taken as 1 day, okay? So I take my measurement on a daily basis. So my unit time is 1 day, okay? And within the day, okay, or within the 24 hours, if he takes the pills X, then he will, in other words, in his bloodstream, the amount of vitamin A is increased by 1 milligram, whereas the amount of vitamin B is decreased by 1 milligram. Okay, then, if the increase in the bloodstream of some vitamin is represented by plus sign, then the decrease should be represented by one minus sign, right? Okay, say it -1. And the gain for vitamin C, in other words, if I take the pills X, then the amount of vitamin C is increased, say, by 1 milligram. So here's the contribution of using X in terms of the amount of these three different vitamins. So in other words, in this row, we see that if the patient takes the pill X, then within the 24 hours following using that pills in his bloodstream, the amount of vitamin A's and C's will be increased by 1 milligram, whereas the amount of vitamin B will be decreased by 1 milligram. Okay. How about vitamin Y? How about, pills Y? If I take the Y, then suppose the amount of vitamin A is increased by 1 milligram and the amount of B is increased by 2 milligram, and the amount of vitamin C is decreased by 1 milligram. Okay, and minus sign again represents the decrease, whereas in other words, the decrement in the amount of vitamin in that specific, in that corresponding vitamin, and the plus sign corresponds to the increase of the amount of that vitamin. And if he takes the Z pills, then say this is the increase or decrease of the amount of vitamins. And if you notice that if the patient takes the Z pills, the amount of vitamin A is decreased by 1 milligram, whereas there is no change in the amount of vitamin B, no increase, no increment or no decrement, right? And amount of vitamin C is increased by 3 milligrams. Okay. And on a given day, another restriction, let's say one more restriction. On a given day, okay, this patient actually is allowed to take only one of these pills. So no more than one pill. On a given day, on a given arbitrary day, he will either take X or Y or Z, but not more than one, okay? Only one. Only one of this. Here's another restriction. Alright then. Now, the question is this. Here's the statement of our problem, okay? Here's our real life scenario. Alright, and my question is that, is it possible to meet the required total amount of vitamins by using some combinations of these 3 pills? And if so, how many days will it take for the patient to reach to the desired amount of vitamins? This is the question. So, okay, we will try to find the number of times, in other words, right, by saying a combination of these 3 pills, I mean how many times should the patient use X pills or Y pills and Z pills? And we are looking for such a combination that would satisfy the required total amount of vitamin. Okay, so here is the problem, and let's get back to the solution. Now, how can I solve this? Okay, first of all, I need to convert my problem into a system of linear equations, right? We need to convert this problem, this original problem, this real life scenario, into that of what we know as systems of linear equations. And how can we do that? Okay, so what should I do? There are actually, first of all, we are required to find the number of pills that this patient will use, okay? So the unknown variables are X, Y, and Z. That's one thing for sure, okay? And the second thing we should decide, well, first of all, we decide what the unknown variables are, right? Because this is one of the key components of a system of linear equations. We need to decide what the unknown variables are, and then what the right hand side values are, and then what the coefficients are. If we find all of these values, then we have the system, right? We have the system of linear equations. And also another thing is that how many equations should I have? All right, this is another concept that we should be aware of. Okay, and X, Y, Z is the unknown variables, and how many equations should I have? All right, then I'm given 3 different constraints, right? One equation should correspond to the total amount of vitamin E, whereas one equation should correspond to the total amount of vitamin B, and one equation should correspond to the total amount of vitamin C. In other words, there are 3 different values given to us to follow, and therefore I have 3 equations, each of which represents the amount of vitamins, right? So one equation is for the total amount of vitamin A. For instance, let's start with the first equation. Okay, the very first equation on the top represents the total amount of vitamin A, okay, gained so far. And equation number 2, suppose it represents the total amount of vitamin B obtained so far. And say the third equation corresponds to the total amount of vitamin C that has been obtained so far. Alright, now I know how many equations should we have. We need to have 3 equations with respect to this real life scenario, right? Because I need to find the value of 3 different amount of vitamins, and these are the given data, right? These are our restrictions. And I have 3 unknown variables. How do I understand that? Because I am asked to find how many of either of these pills should be taken by the patient, right? So I need to find the number of each pills taken by the patient. So X, Y, and Z are nothing but the unknown variables. And how about the right hand side values? This is also one of the important things. Alright, this is simple because if each equation is associated with the total amount of each vitamin, right, from top to bottom, say A, B, C, and then we are given the requirement, right? We are given how much of each of them should be taken. For instance, for vitamin A, we should have 20, right? So this equation should be equal to 20 because the total amount required for vitamin A is 20 milligram, and for vitamin B it is 30, and for vitamin C it is 20, and just put the values right here on the right hand side of each equation. So now our system started to be clear, right? Started to be more clear to us. So as you see, we're almost done, besides one thing. And what is left here? So what is missing here, actually? What is left to us to do is, of course, find what the questions to be. Maybe let's raise them, because we can have also negative signs, right? We can have minus sign here, depending on the given data or given conditions. Okay, sure. So here, let's look at the situation. Alright guys, here's the thing. Vitamin A can be contributed by each of these 3 pills. And vitamin B, the same thing is valid for the vitamin B as well, and vitamin C. Alright, so either an increment or a decrement, but the total amount of all these vitamins will be decided by how many times these X, Y, and Z pills are taken by the patient, and what is the contribution of taking these pills, either of these pills, to the total amount of each of these vitamins. Okay, let's start with the very first one, vitamin A, the first equation. Alright, so here's the thing. If I take, okay, since the first equation corresponds to the total amount of vitamin A, now I will take into account taking each of the pills and their contribution to the total amount of vitamin A. Okay, if I take the pills X, then what is the total contribution? It is +1, right? Because I know that if I take X, then the amount of vitamin A is increased by 1, right? So a little bit, like move it downwards, right? Let's see. And so the coefficient of X is 1. I don't even write it. How about Y? If I take Y, then what is the contribution? Right? Again, my contribution is 1, right? You see that? So here's 1. And how about z? And this is -1, right? Okay. And the same thing is for vitamin B. Okay, -1, 2, and 0. Alright then, so -1, I put the values here, and +2, and the contribution of taking pills Z to the total amount of vitamin B is what? It's 0, right? So I can simply erase this, or I just can write as 0 over here, so it doesn't matter, because I will convert the system into an augmented form, right? So that doesn't matter. Okay. And for the last equation, and the coefficients are what? The coefficients are 1, -1, and 3, right? 1, -1, and 3. Alright. Alright then. Now, I have the system. I know the equations in each system, right? I have 3 unknown variables here in the system and 3 equations, so just convert them into its augmented form and put the coefficients there. 1, 1, -1, and 20. And -1, 2, 0, 30, and 1, -1, 3, and 20. Right. Now, is this matrix in row echelon form? And the answer is of course no. So we should eliminate these values, right? We should turn their values into zeros. And how can I do that? It is very clear. I need to replace both row 2 and row 3. Okay, and row 2 is replaced, you see, by row 2 plus. If I add the first row to it, then I obtained required value. And then for row number 3, okay, row 3 plus -1, row 1, right, to eliminate these values. And now our matrix becomes 1, 1, -1, 20, and this is 0, right? This is 3, this is -1, and this is just 50. And the row number 3, when we subtract the third row from the first row, right, we got 0 here, we got -2 here, we got 4 here, and we got 0 here, right? So I eliminated these values. Now what is missing is I need to eliminate this value as well, right, to convert it into row echelon form. So what should I do? So I need to replace row 3. Row 3 is replaced by row 3 plus by using elementary row operations. Okay, so I needed 2 here, so I should multiply the second row by some real value that would make this value 3 is equal to 2. So that when I add the second row to the third row, I will eliminate this minus 2 value. Okay, so how can I do that? It is simple. If I multiply the second row by 2 over 3, right, and add it to row 3 and replace the row 3 by the right hand side equation, then I'm done. Okay, let's move on. Let's move it a little right to the right, and our new matrix becomes, okay, so no change in the first row, just write them here, the same values, and no change in the second row as well, but third row, okay, this is 0, this is also 0, so multiplying by 2 over 3, it is minus 2 over 3, and 4 minus 2 over 3, right, as simple arithmetic. When we equalize this denominator, we got 10 over 3, right? Okay. And in the last entry, what we got? We got 100 over 3, guys, right? 100 over 3, right? So this is the row echelon form we reached, right? Now it is in the row echelon form, right? So we are done with the Gaussian elimination method, right? In order to solve the system of equations, I applied Gaussian elimination method. How do I understand that? Because Gaussian elimination method is a process where we convert our augmented matrix into the row echelon form. And we obtained our row echelon form, and let's keep doing our computation. Now, starting at the last row, okay, so by applying back substitution method, 10 over 3 times z is equal to 100 over 3, right? And 3's are cancelled out, and 10's are cancelled out, and so what we got here is z equal to 10, right? And put this value in the row right above it, right? So in other words, here in the second row, now what we get here, we got 3y minus z, which is 10, okay, is equal to 50, and then moving this value to the right hand side, we got, 50 plus 10, this is gone, so 3y is equal to 60, which means y is equal to 20, right? And then what? So one thing left behind just for us to end this computational process. So x plus y, in this case y is equal to 20, right? Minus c, and z is 10, and then is equal to 20. So 20 minus 10 is equal to 10. Moving it to the right hand side, right? 20 minus 10 is equal to 10. So we have found the value of x as well as 10. So putting the pieces together, what we have found? Okay, our solution is, we already found both values of x, y, and z, which are the unknown variables for the system. And here is the solution set. X is equal to, right, x, y, z, x, y, and z, and this is nothing but the solution we found. So x is 10 and y is 20 and z is also 10. Alright, now we found our solution, right? Here is the solution set we obtained. Okay, so what can we say about the solution? Remember what we were looking for. Okay, you know, we were given some required amount of vitamins that need to be satisfied in terms of amount, right? In terms of their amount. And we are given an option of using either of these 3 pills on a given day, but no more than one, just one on a given day, of course. And the contribution of using each pills to the total amount of vitamins are given in a table form, and then we convert our problem into a system of linear equations, and by applying Gaussian elimination method we found the solution set to the problem, which is actually the times that we use each pill, right? So this means that this patient should take 10x, right, 20y, and 10z. This is the way that this patient should take this pill. So a combination of these pills means that 10 times x are used and 20 times y are used and 10 times z are used. So on a given day the patient is allowed to take only one of these pills. So this means that how many days will it take to end the session, right? To, in other words, meet the required amount of vitamins with that restrictions given. Okay, so we just need to sum these values up, right? 10 plus 20 is equal to 30 and plus 10 is equal to 40. Then 40 days would be enough. Okay, after 40 days, right, or after 40 days of using this combination of these 3 pills with the numbers that we have just found and under these restrictions of total amount of vitamins, then we obtained our desired result. Alright guys, I believe that we have seen a much more interesting real life scenario in this video. And that's it for this lecture, and see you in the next lecture guys, and until then, have fun.